What's going on, everybody? Welcome back to my YouTube channel. Look at this nice and beautiful question on the board that we're going to be solving. And the question says, find the values of x for which 4 to the x plus 25 to the x is equal to 10 to the x plus 1. Well, our first step will be for us to apply the property of indices to the right-hand side. And this property is, for example, when I have a to the m plus n, this can be expressed as a to the m times a to the n. So let's express this like this. So we have 4 to the x plus 25 to the x to be equal to, now this can be expressed as 10 to the x times 10 to the power of 1. But I'm not going to be putting a 1. The 1 is going to be invisible because 10 to the 1 is same as 10. Our next step will be for us to get rid of this 10 to the x from the right hand side. And we're going to do that by dividing through by 10 to the x. So I'm going to be dividing 4 to the x by 10 to the x. I'll divide 25 to the x by 10 to the x. I'll divide the right hand side by 10 to the x. Now notice that 10 to the x can cancel off so that we have 10 remaining on the right hand side. Now from the left hand side, we're going to apply the property of indices, which says if the powers are the same, or if we have common powers, we can as well group the powers. So this becomes 4 over 10 to the x. So you notice that we've already grouped the powers. Plus, we're going to be doing the same thing here. This becomes 25 all over 10 to the x equal to 10. Our next step will be for us to break down what we have here. So notice that 2 can divide 4. So 2 divide 4 is 2. 2 divide 10 is 5. So we have 2 over 5 to the x. Plus, now from here, you notice that 5 can divide 25 and 10. So 5 divided by 25 is, we have 5. Then we have 5 into 10, we have 2. So this is 5 over 2 to the x equal to 10. Now notice that 5 over 2 is actually an inverse to 2 over 5. That means we can write 5 over 2 as 2 over 5 by writing it in form of an inverse. So this is what I mean. This is 2 over 5 raised to the x plus, now this expression will be written as an inverse as 1 all over. Remember, the aim is to write it in the form of 2 over 5. So 2 over 5 now raised to the x. So this is valid because of this 1 on top equal to 10. Now notice that we have 2 over 5 to the x here, and we also have 2 over 5 to the x here. So we can therefore introduce substitution by saying let 2 over 5 to the x be equal to u. That means wherever I see 2 over 5 to the x, I'm going to be putting u there. So this expression becomes u plus 1 all over u equal to 10. Our next step will be for us to combine the fraction on the left hand side by taking the LCM. So the LCM is u. I'm going to be putting over 1 here. So u divided by 1 is u times u, that's u squared, plus, now u divided by u, that's 1 times 1 is 1. And this is equal to 10. Now let's cross multiply. So when I cross multiply, I'm going to be having u squared plus 1 to be equal to u times 10 is 10u. Now let's move everything to one side. And we're going to be doing that on the next slide. So now moving everything on the right to the left hand side, we have u squared. So as 10u crosses to the left, it becomes negative 10u and then plus 1 equal to, since nothing now remains on the right, this becomes 0. So this is a quadratic equation. And we're going to be using the quadratic formula to solve this. Now from this quadratic equation, a is the coefficient of u squared, which is 1. B is the coefficient of u, which is negative 10. And c is a constant term, which is 1. So since we're looking for u, using the quadratic formula, u is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So now let's substitute. So u becomes negative b. B is what? Negative 10. So let's put negative 10 there. Plus or minus the square root of b squared, that's negative 10 squared, minus 4ac. A is 1 and c is also 1. All over 2 times a, that's 2 times 1. So this simplifies into u to be equal to minus times minus gives positive 10 plus or minus the square root of, now negative 10 squared is actually 100 minus 4 times 1 is 4 all over, now 2 times 1 is 2. So this becomes u equal to 10 plus or minus the square root of, now 100 minus 4 is actually 96 all over 2. Now let's decompose 96 such that we use two factors, whereby one factor is a perfect square and another factor. So u is equal to 10 plus or minus. Now the perfect square I'm going to be using is 16. So 16 times 6 gives 96. So all over 2. So u now becomes 10 plus or minus. Now the square root of 16 is 4, then root 6 all over 2. Let's continue on the next slide. Now notice that 2 is actually common on the numerator. So we're going to be factoring out 2 so that we have u to be equal to, now factor out 2. 10 divided by 2, that's 5, plus or minus. Now 4 root 6 divided by 2 is 2 root 6 all over 2. So this leaves out u to be equal to, 2 can cancel out 2, to be equal to 5 plus or minus 2 root 6. So this is a value for u. There are actually two values. So u is either 5 plus 2 root 6, or u is equal to 5. Now take the negative, minus 2 root 6. But now let's recall. Recall that we said 2 over 5 to the x is equal to u, right? Cool. So now we're going to be taking the value each values for u and substitute it here. So let's start with the first one. So when u is equal to this, which is 5 plus 2 root 6. So this becomes 2 over 5 to the x to be equal to u. U is 5 plus 2 root 6. Now notice that the unknown is an exponent. And whenever we have unknown as an exponent, what we usually do is to take the log of both sides. So we take the log of the left hand side. So we have log 2 over 5 to the x to be equal to the log of the right hand side, which is 5 plus 2 root 6. Our next step will be for us to apply the property of logarithm, whereby the exponent moves to the back of the logarithm or moves behind the logarithm to multiply it. So this becomes x, which is the exponent, now multiplies the log of 2 over 5 equal to log 5 plus 2 root 6. Now, in order to get the value for x, we're going to be dividing both sides by log 2 over 5. Let's do that on the next slide. All right, so I'll divide the left-hand side by log 2 over 5. I'll also divide the right-hand side by log 2 over 5. Now notice that log 2 over 5 can cancel off, leaving x to be equal to log 5 plus 2 root 6 all over log 2 over 5. So this is one of the answers. Now let's go for when u is equal to 5 minus 2 root 6. Well, we are actually going to have an expression that looks like this, but x will be equal to, following the normal process, x will be equal to log 5 minus 2 root 6 all over log 2 over 5. So these are the two values for x. Well, feel free to share your ideas in the comment section below. And if you enjoyed this video and have learned something from this video, go ahead and give this video a thumbs up. Subscribe if you haven't. Turn on the notification bell so you don't miss my upcoming videos. And like I always say, until next time, take care.